lecture number 3rd. I am Dr. Purvez Ahmed. In today's lectures, we will proceed with the basic concept again. And today's basic concept is elements. It means that in today's lectures, we will have a discussions on the elements, about the elements type, and how the elements are being classified in the form of periodic tables. And in the last sections, we will deal with how different elements they interact and found the different kind of compound. So let's proceed towards today's lecture. So element, whenever you heard the word element, so you have a question in mind that what is an element? So an element is a substance made of a single type of atom. Different type of the atom we have in the periodic table that we will discuss later on in this lecture. But if you found a substance that consists of many atoms, or there are being made up many atoms of the same type, so that we call an element. And we remember, an element cannot be broken into sample component by chemical process. You have an element made up various atom of the same type. So you want to break that element, so you cannot break it into smaller component by a sample chemical process. uh, how many elements we have naturally or artificially? So we remember, naturally we have 92 elements that we will discuss later on. And the other elements, we have also artificial element that we can make in the laboratory, that we can also, or we will discuss later on in this lecture. So we remember, the element may be solid, the element may be liquid, or they might be in the gaseous form. So we discussed in the last lecture about the number of protons and number of neutrons, and their importance for the atom. So the same importance they have for the element. Just like we mentioned that the number of proton in atom dictate uh, the atom characteristic. So similarly, it dictates the element. Just like the proton do for the atom, so the same it do for the element. Just for example, we have hydrogen atoms, we have helium, and we have carbon. So in a hydrogen, you know that we have one proton. So the one proton is basically what? It's the atomic number of the hydrogens. And along with that, it has one electron and zero neutrons. So then we have the helium atom. So the helium atom, it has two protons, two electron, and two neutron. So the number of protons it dictate, it's the identity of the helium atom. So just like that, we have carbon atom. Carbon atom has six protons, six electron, and six neutrons. And just like we're mentioning here, that protons, the number of protons, it dictate the element. So here, carbon, it has six protons, so atomic number is 6, and it's basically dictate the element of the carbon. So for an earth charged atoms, the number of electrons equals the number of the protons. What it means? It means that an atom or an element, it normally remains neutral until unless it lose or share an electrons. Until unless it do not lose an electron, so the atom it's remain neutrals. So what it mean? It means that normally in an atom or an element, the number of protons equal to the number of electron. So proton and electron numbers equal. So the charges are being balanced. You know that the proton, they have positive charge, the electron they have negative charge. So as long as in the atom the number of protons equal the number of the electrons, so the charge, they are being neutralized. And the charge is unbalanced when an atom or an element it lose the electrons by making a chemical compound. So in that case, we say that the charge neutrality, it's being changed. So here in this slide you can see the 10 most abundant atom, the most abundant element in the universe. I mean, these are the 10 most abundant element in the nature. So at number first we have the oxygen, and for the oxygen we have the symbol O, and it has 8 number of protons, and its relative abundance on the earth is equal to 46.6%. At number second, we have silicon. For silicon, we have the symbol Si. It has 14 protons, and it has 27.7% of the Earth mass. Uh, then we have number third, aluminium. The symbol is Al. Number of proton 13, and relative abundance on the earth mass is equal to 8.1. At number third we have iron. The symbol is Fe. Number of protons are 26, and its relative percent of the earth mass is 5. uh, then we have calcium. Calcium symbol is Ca. Number of proton 20. uh, Relative percent of the earth mass is equal to 3.6. Then we have sodium, symbol Na. Number of protons 11. Relative percent of the earth mass equal to 2.8. uh, we have potassiums. Potassium has the symbol K. Number of protons 19. Relative percent of the earth mass 2.6%. Then at number 8 we have magnesiums. The symbol for magnesium is Mg. The number of protons the magnesium has equal to 12. Relative percent of the earth mass is equal to 2.1. At number 9 we have titaniums. So titanium symbol is Ti. Number of protons the titanium atom has 22, and relative percent of the earth mass is equal to 0.4%. At number 10 we have hydrogens. The hydrogen symbol is 1. The hydrogen symbol is H. Number of protons the hydrogen atom has 1, and its relative percent of the earth mass is equal to 0.1%. So these are the 10 most abundant elements on the earth surface. So periodic table of the element, what is mean by the periodic tables of the element? So just like you people learn in the basic classes, like in your matriculations or your intermediate classes, that all the elements that either found naturally or they're found or they're being made in the laboratory. So all these elements, they are based on organized and a tabular form. So these organizations of the element and the tabular form is called periodic table of the element. The idea for the periodic table was first given in 1869 by Russian chemist Dmitry Mendeleev. Uh, Mendeleev first described an arrangement of the chemical elements known as the periodic tables. I mean, he called that periodic tables because he mentions in his detailed discussions that the properties of the different elements, they are being repeating at a particular intervals at particular period. So that's why he called that periodic table. So the periodic table displays all the chemical elements systematically in order of increasing atomic number. I mean, the number of protons in the nucleus. So before the Mendeleev, there was also so many attempts for the arrangement of the elements in the form of a table or in tabular form. I mean, before the Mendeleev, the people tried to arrange the element on the basis of the atomic masses. So you know that then we have the problem of the isotope. So when the isotope was discovered, so the arrangement of the, we have the problem with the arrangement of the element, that people ask the questions that how to arrange or how to place the same element, I mean the different isotope of the same element in the tabular form. So then the Mendeleev came, and Mendeleev gave the idea that the basic characteristic of the atom is the number of the proton, or proton is the identity of the atom. So this solved the problem of the isotope, and accordingly the elements they are being arranged in the form of a periodic table. So here you can see the periodic table of the elements. So these are being the arrangement. You can see it here. I mean, it's different series. I mean, it's the just like here you can see that in the middle, these are called what? These are called the transition elements. I mean, 1B, 2B, 3B, 4B, 5B, 6B, 7B. All these are the transitions, the transition elements. So from here onward, you can see it here from this place, from here to here. These are the metal. I mean, group 3, 3A, 4A, 5A, 6A, and 6A. From 3A to 6A, these are all metal except the boron, because boron is semi-metals, or is also called metallite. So group 7A and 8A, these are called non-metal, which are being further divided into two groups. I mean, group 7A is they are called halogens, and group 8A they are called the normal gases, or we can also call the inert gases. So when you come here, I mean group A first, so they are called, except the hydrogen, they are called alkali metal, and group A2 they are called alkaline earth metal. And when you come here, I mean it's atomic number 58. So from here onward, from atomic number 58 to atomic number 71, so this is another series of the atom or the element that we call inner transition elements. So the first series that we have from here, from 58 to 71, this is called lanthanide series. I mean, these are the element, the series of the element that we call lanthanide series of the element. And from 90 to 103, there is another series of the element. I mean, that is from thorium to this particular element, and this being called as actinide series. And both of these they are called rare earth elements. So again here you can see, I mean we have visualized different element or their series or their group with a different color. So here you can see that except the few elements, they have different characteristic as compared to the rest of the periodic table. So here you can see it here. This is the periodic table. I mean the different colors, I mean it's mentioned here what these different color mean. And this is the lanthanide series and actinide series. So here you can see that, so what actually mean by the different color. So here you can see that hydrogens, here is the hydrogen, it's the gas. And then we have lithium. Lithium is a solid. Then we have bromine. Bromine here, this red color, it's a liquid. And um, this we have technetium. Technetium. Technetium is basically synthetic. So what actually mean by the different colors? So here you can see that this color basically show that these are the non-metals in the periodic table. So here you can see that what are the non-metal in the periodic table. So these are the non-metal in the periodic table. So the yellow color, this color is represent the alkali metal. So here you can see that all these are the alkali metal. Then you can see the transition metal. So all these are the transitions. Uh, these are the transitions metal. So here you can see all these the transition metal, the alkaline earth metals. So these are the alkaline earth metals. Then you have the rare earth metals. So the rare earth metals, you can see that all these, they are the rare earth metals. So you have the halogens. So here you can see that all these are the halogens. Here you should remember, we have the color for the sample. Here you can see that hydrogens, hydrogen is a gas. So here the color, its color is blue. So like the hydrogens, we have nitrogen. Here you can see that the sample color is blue. So it's mean that in this group, the nitrogen is a gas. Similarly, in this group, the nitrogen is gas. And also in this group, fluorine and chlorine, they are the gases. And here you can see that if the symbol is black, so black mean that that element or that atom, it will be in the solid form. So here you can see that in the first group, that is group here 1, lithium, sodium, potassium, rubidium, they are all in the solid form. And here again you can see that uh, if the element color, the sample color is red, so it's mean that that would be in the liquid form. So here you can see that the cesium sample color is red, so it's mean that it's in the liquid form. So the sample color is basically shows that it's form, that whether it will be in a gas form, solid form, or the liquid form or synthetic form. So here you can easily identify it for yourself. So here you can see that all the colors, they are of the same type, and the group A8, they are called the noble gases or inert gases. So all these are in the gaseous form. And group A7, you can see that we have fluorine, we have chlorine, they are in the gaseous form. We have bromine in the liquid form, and we have iodine and the other two. The other one is in the solid form. Similarly, one B group, we have other elements. They are the solid form except the mercury. Mercury is in the liquid form. So this is how you can understand the periodic table. Here you can see that here in the lanthanide series, this particular element with the atomic number 61, it is in the synthetic element. We can form it in the lab. And similarly, we have actinide series. In actinide series, we have these synthetic elements. You can see it here for yourself. So how do the elements react each other? It's the questions that we have different element in the periodic table. They have different characteristic. You people have studied the chemistry and your previous classes, so I think you have some of the basic knowledge of how do the element react with each other. So we just want to repeat the concept that how do the elements they interact. So when the two atoms approach each other's, the nuclei never get close enough to interact. And you know the reason that why the nuclei it do not come closer to each other, because the nuclei, all the nuclei, they have positive charges. We mentioned already that the atom has only positive charges at the center or at the nucleus. So that's why the nuclei in a chemical reaction cannot get closer to each other. And why? Because they repel each other due to the Coulomb repulsive force. Positive charges, they repel each other. So that's why nuclei cannot get closer to each other in a chemical reactions. So how do the nuclear reaction, how do the chemical reaction occur? So we remember, during a chemical reactions, only the electrons of the atoms interact with each other. I mean, the reason for the chemical reaction is the activity of the electrons and the atom. The electrons of the atom, they interact with each other, and just because of these reasons, the chemical behavior of the atom is determined by its electrons. Particularly the number of electrons in the outermost shells. Atom has electrons and different shells, And these electrons, it basically determines the chemical behaviors of the particular atom. I mean, and these electrons, are being presented different. They are being presented at different shells. So all these electrons, I mean, they are involved in different activity. So when it comes to the chemical bonding or the interaction of the electron, so the most active electron in this particular phenomena, I mean, the electron who's been responsible for the chemical activity are those which lies in the outermost shells, and those outermost shells we call it valence shells. And it are those electrons are being responsible for the chemical behaviors of the elements. So that the electrons that remains in the outermost shell and elements, we call that valence shells electrons. And these are the electrons which are responsible for the chemical interactions or the chemical bonding of an element. And the shells, the last shells of an atom or an element, we call that the valence shells. So an atom that has maximum number of the valence electron in its valence shells will be chemically unreactive, forming no bonds with the other atoms. I mean, this fact also, I mean, from your basic chemistry that if an atom has outermost filled shell, so it's chemically remains unreactive. I mean, it's not interested in the chemical bonding. So however, an atom which does not have the maximum number of valence electron in its valence shells will be chemically reactive. I mean, the less number of the valence electron the atom have, the more reactive it will be. Or we can say that the maximum number of the unfilled electrons an atom has, the more reactive it will be. So one way to think of this is that an atom will react with other atom if it can fill its valence shells with the electrons by doing so. I mean, uh, the atom that can be considered the reactive if either it has excess electrons to give it to the other elements, or it has the tendency to gain the electron from other element. I mean, uh, those elements, they are being considered as reactive which has either the tendency of gaining or giving electrons. So the chemical reactions mostly occur between those element, which has either the tendency of giving, sharing, or taking the electrons. So here we have a good example of the element, sample element zirconium. So you know that zirconium has a total number of protons equal to 40, and the total number of neutrons that zirconium has equal to 51. So the atomic mass of zirconium is equal to 91, and the atomic number of zirconium is 40. So electronic shell can be configurations of the zirconiums will look like, that is, in K shells it will have 2 electron, and the L shells, you know that it has 2 subshell, 2s2, 2p6. So total number of electrons it will have equal to 8. Similarly, in the M shells, it will have the electrons. The total number of electron in the M shell will be equal to 18. And this 18, it will have 2 electron in 3s shell, 6 electron in 3p shells, and 10 electron in the 3d subshells. So similarly, in the N shells, the total number of the electrons that zirconium has is equal to 10. And the O shell, that is the outermost shell that we also call, the valence shells, zirconium has only 2 electron. So here's is the combinations. If we add all these electron, so we get 10 plus 18 plus 12, so is equal to 40. It's the total number of the electrons that the zirconium has, and it's the electronic shell configuration of the zirconium. I mean, that is how we divide the atom and different shells and subshells of the zirconium atom. So here, I mean, the sample atom zirconiums, it has the name zirconium. The sample for zirconium is ZR. Atomic mass equal to 40. Sorry, atomic number is equal to 40. Atomic mass, I mean, the exact atomic mass is equal to 91.224 AMU. Melting point is 1852 degrees centigrade. Melting boiling point 4377 degrees centigrade. Number of protons or number of electrons equal to uh, 40. I mean, that's the same number, that is uh, the number of proton that we call the atomic number. So number of neutrons in zirconium atoms is I mean, they are equal to 51. So classifications, we remember zirconium is being classified as transition metal. I mean, zirconium is a transition metals, and it's normally exist. I mean, its room temperature it exists in the solid form. Density at 293 Kelvin is equal to 6.49 gram per centimeter cube, and the color of zirconium atom is grayish. Uh, and Zirconium was discovered by Martin Klefroth, and that was in 1789. So that's all we have for this lecture. Thanks for watching. I hope that you get some idea that what is an element, and how we can identify an element, and how the elements they are being organized in the form of periodic table. Hope you enjoy the lectures. So stay tuned with the next lecture, because in next lectures we will have a discussion on I mean, we will continue with the basic concept and the nuclear physics, but in the next lectures, we will have discussions on the isotope. I mean, we will discuss that what the isotopes are, how the isotopes are formed, and how do the isotope, I mean, they exist. So stay tuned with the next lecture. See you soon there. Till then, bye bye.